welcome to lesson 80 on prime and composite numbers. So prime numbers have only two factors, themselves and 1. So for an example, 7. You cannot divide 7 by any other number besides from itself and 1. Same thing with 3. Same thing with 2. Composite numbers, there's a lot more of them, and that's any number that has more than two factors. So for an example would be 4. You can multiply 2 times 2 to get 4. 12, you can multiply 3 times 4 or 2 times 6. So if they have any factors at all besides themselves and 1, it is a composite number, which means that I can divide these numbers. So I can divide 12 by 6 or by 4 or by 2 or by 3. I can divide 4 by 2. I can divide them by numbers besides themselves and 1. In other words, if you can divide a number by anything other than itself and 1, it is composite. Here is an example. Write whether each number is prime, we're going to show with a little p, or composite with a c. So I have a little chart for us to fill out. What about the number 2? What factors does 2 have? 1 and 2. So because the only factors are itself, which is 2, and 1, is that prime or composite? It's prime. Okay, what about 3? 3's factors, it has 1. Is 2 a factor? No. And 3. So its only factors are 1 and itself. So this one is also prime. What about 4? Well, 4 has 1, 2 times 2, and 4. Does it have any other factors besides from itself and 1? Yes, so this one is composite. What about 5? It has 1, doesn't have 2, can't divide it by 3, you can't divide it by 4, you can divide it by 5. The only factors it has is itself and 1, so this one is also prime. What about 6? Are you starting to get the hang of it? You can divide it by 1, you can divide it by 2, you can divide it by 3, you can't divide it by 4, you can't divide it by 5, you can divide it by 6. It has more than two factors, so it is composite. Okay, why don't you do the other 3 on your own? Okay, what about 17? Can I divide 17? I can divide 17 by 1. I can divide it by 17. I can't divide it by anything else. So this one is also prime. What about 21? This one's tricky. A lot of people often think that it's prime. I don't know exactly why, but I guess it just looks like a prime number. But what two factors can I multiply to get 21? I can multiply 3 times 7 to get 21. So because it can be divided by another number evenly, it is composite. What about 48? Okay, let's go to page 2. So, it's worthwhile to memorize the first bunch of primes. They are 2, 3, 5, 7, 11, 13, 17, 19, 23. Those ones get used a lot, especially up to like here. You should memorize them. It will make your life much easier, and you're going to need to know them when we start factoring, which is coming up pretty soon. The last thing that's in this lesson is it talks about an array. An array is a rectangular arrangement of numbers or objects in rows and columns, and we've used arrays to show multiplication before. So draw 3 different arrays for 12. I'm just going to use an X to represent each spot. So 3 by 4 means that I'm going to do 3 down, 1, 2, 3, and 4 across, 1, 2, 3, 4. And then I'm going to fill it in. How many X's did I just draw? 12, right? When I draw an array, it's always going to represent the number that it's for. So I showed that I can do 3 by 4, which means that it is a composite number because I can make an array that is not just a straight line. If I were to do 2 by 6, which is another array for the same number, I would do 1, 2, 1, 2, 3, 4, 5, 6. This also represents 12 but it shows 2 times 6. Or I could do 1 by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, all 3 of these are arrays for the number 12, but they also show us something else. If I were to turn it this way, it gives me 3 more arrays. So I could do here 4 by 3, or 6 by 2, or 12 by 1. Now, a prime number, the only type of arrays you'll ever be able to draw for it are going to be straight lines like this one. A composite number you can also draw a straight line array for, but there's also options that you can draw that make more rectangular shapes, okay, that aren't just a straight line. So if I were to draw an array for 11, then I could do 1 by 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or I could do 11 by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now both of those arrays make a straight line, and there's no other type of array I could draw for that number. All right, here's one that I want you to try on your own. It says draw 2 different arrays for 6. So I want you to come up with 2 different ones and draw them down here for the number 6. Before we go, I have a song for you. For your enjoyment, a song on primes.
It's a number greater than 1. Divisors, it's got none. The only number that goes into it is 1. If I think hard, I think I could name some. I will try until I got it. These numbers are prime and not composite. A lot of people might not know, but I think I'll give it a go. This is my prime song. I sing it all the time, song. Gotta give it a try, song. So many numbers, one than another. I sing my prime song, and I don't really care if nobody else will hear, 'cause I've still got a lot of prime numbers here. The prime numbers start with 2 and 3, 5, 7, 11, and 13, 17, then 19, 23, and 31, 37, then 41, then we see 43, 47, 53, how many more can there be? 59 and 61, 67 and 71, this is my prime song. I sing it all the time, song. Gotta give it a try, song.
All right, guys, I hope that helps. I look forward to seeing you tomorrow. Go ahead and get to work.